Good morning, dear students. Welcome to the class. How are you all? Hope that you all are safe and fine at home. By now, we have covered a lot of topics, and I hope that you are learning it at home. Those who have not started it yet, there is a reminder, kindly start learning, because when the regular interactive classes will resume, these topics will not be covered again. Only your doubts, if any, will be answered. So let's recap what we have discussed in the previous sessions. We have discussed about matter. What is matter? Matter is anything that occupies space and has mass. Then we have also discussed about the most common example, that is water. Water is found in all the three states, that is solid form, in the form of ice we find it. In the liquid form, the water which we drink is the liquid form of it, and in the form of water vapor, that is the gaseous form of water. All these three forms of water can be interchanged. Means the solid form of water can be changed into liquid form. When it will be changed? It will be changed when we heat, or if we keep the ice cubes at room temperature, the ice cubes will melt and it will change into liquid form. So the change will take place from solid state to liquid state. This liquid state of water, if it is heated, if we take it in a container and keep it on the gas stove, it will be heated and it will start changing into gaseous form. That will be water vapor. So water in the ice form, when it is changing into liquid form, and from the liquid form when it is changing into gaseous form, we find a change taking place. But is it that the chemical composition of the substance changed? No. Only the change is taking place in its physical form. So we consider that the change from solid to liquid and from liquid to gaseous form in water is a physical change which is taking place. So what is a physical change? A physical change is a change in which no new substance is formed, as in case of water, when ice cubes change into liquid form of water, we don't find any change in the chemical composition of the substance. That is why we say there is no new substance formed. The original substance is water only. Now, these changes are easily reversible. Easily reversible means when the water is again kept in the refrigerator, what will happen? The water will change into ice. Yes. Therefore, we consider such type of change as temporary change, because it can be easily reversed. Another example is dissolving salt in water. Already we have discussed about melting. Another example is boiling. When water is boiled, it will change into gaseous form. So, changing of solid form of water to liquid form of water, and then the liquid form of water, when it is changed to gaseous form of water, we consider all these three changes as physical change. Now, what is chemical change? Chemical change is a change in which a new substance is formed. For example, curdling of milk. When from the milk curd is formed, what do you find? Is the original substance milk present there? No, it's no more milk, but it has changed to curd. So such type of changes are said to be chemical changes, where a new substance is formed. And if we try also, then too we cannot get back milk from ice. So we consider this change as irreversible change. And because it is irreversible in nature, means we cannot get back the original substance, we call it a permanent change. And we can also consider that the new substance which is formed in the change has different property as compared to the original substance. Milk was entirely different. It has different properties. And when we talk about curd that is formed after the change, it has entirely different property. So it is considered as a chemical change. Now, we have also discussed about matter, that it is anything that occupies space and has mass. So matter is broadly classified as pure substances or mixtures. Mixtures are also called as impure substances. So what are pure substances? Those substances which are made up of one kind of particles. Such substances are considered as pure substances, whereas mixtures are those substances which are composed of different particles, or you can say different substances are put together, are mixed together, and they form the mixture. Now, the pure substances are further classified as elements and compounds. And mixtures are classified as homogeneous and inhomogeneous, or we can say heterogeneous mixtures. So I suppose it's very clear to everyone that matter is classified as pure substance and impure substance, which is called as mixture also, and pure substances are further classified as elements and compounds. So our topic for the day is elements. What is an element? Here it says, an element says to us, I am a pure substance. What it is? I am a pure substance. I cannot be broken down into any simpler substance by any physical or chemical means. That means an element is the substance, pure substance, which cannot be broken down into much more simpler form. For example, if I tell you the example of gold, if we keep breaking a piece of gold and keep breaking it till the time a small particle of it is left, that small particle of the substance will tell you that it is gold only. It's not going to change. It's nothing else mixed into it. It is gold only. So we consider element as pure substance which cannot be further divided into much more simpler substance. There are different types of elements and each element has different properties, and these properties of elements are different from other types of elements. An element may exist independently or it can combine with other elements to make millions of substances that we see around us. So, what is an element? An element is a pure substance which cannot be broken down or it cannot be split into simpler substances by any physical or chemical mean. For example, again I'll tell you the same example, elaborate the same example. No simpler substance can be made out of the substance like gold. Hence, gold is considered as an element. Other examples of element are iron, silver, copper, and aluminium, and many more examples are there. Many elements are there. We have around 118 elements known till today. Out of these elements, 92 elements are naturally occurring elements and remaining are made by humans. So, an element, it consists of only one kind of atom. That is, same kind of particles. And the smallest unit of any substance or matter is atom only. So we can say that an element, it consists of only one kind of atom. It cannot be broken down into much more simpler form of matter by any means, neither physical means nor chemical means. And we can also say that element can exist as either atoms or it can exist as molecules. Did you get me? Element can exist as either atoms, for example argon, or it can exist as molecules. Now let's move on further. Element is categorized into different types on the basis of their properties, metals, nonmetals, metalloids, and noble or inert gases. So the different types of elements, as you can see here in the flow chart, it shows the different types of elements are metals, nonmetals, metalloids, and noble gases. Now let's move in detail about metals. Metals are the elements which possess certain characteristics. Because of these characteristics, they are put into the metal category. Now, what are those characteristics? As you can see here in the module, there is a list of around 8 physical properties which says that metals are ductile in nature, they are malleable, they are sonorous, they are good conductors of heat and electricity, then they are generally hard, that is why they are solid in state except mercury, its symbol is Hg. Then the density of metals is high except the two metals sodium and potassium. Then metals are lustrous in nature. So these are the few physical properties. Now let's move on in detail about these properties of metals. Metals are generally hard solids. As you can see here in the figure, in the module, you can find so many examples. It is showing iron, silver, gold. Then on the other side you can see it is being hammered. Somebody is hammering the metallic part. So all these are examples of metals which show that they are generally hard. So because these metals are hard, they can be easily beaten into sheets, or it can be drawn into wires. That means with the metal, the metallic sheets can be formed and also wires can be formed. So the metals have this property, that is, they are malleable and ductile in nature. Malleable means it can be drawn into, it can be beaten into sheets, and ductile means it can be drawn or it can be made into, it can be converted into wires. Then another property of metals is it, when struck to a hard surface, when the metal is struck to a hard surface, it produces a particular sound. Which type of sound? I know you are aware of it. Let me tell you. As you can see here in the module, the first figure shows somebody is hitting the bell part of the temple, and when it is hit to a hard surface, we hear a sound. Right now I cannot let you listen that sound, but you have already heard that particular sound. Also in the classrooms, in the school, when the period is going on, when the class is going on, and as it comes to the end, as the class ends, there is a particular symbol which tells that yes, this period is over. What is that symbol? The bell rings. So that ringing of bell is the particular sound which is produced by metals, and that particular sound is called as metallic clink. What it is called? Metallic clink or metallic sound. So metals have this property that they produce a particular sound called metallic clink. Then another property of metals is metals, they are good conductors of electricity. As you can see here, so many electrical appliances are there. This figure shows so many electrical appliances. Microwave is there, then a refrigerator is there, then a vacuum cleaner is there, washing machine is there, then toaster is there. What is required for these appliances to work? We need electricity. So it's not that metals produce electricity, but metals act as the medium for transfer of electric current from the switch to the appliance. So therefore, we consider metals as good conductors of electricity. Now, the next module which you see here, we find so many jewelries, very attractive jewelries. Yes, this is also a property of metals. Metals, they have luster. Luster means shining property. Metals are lustrous in nature. As you can see here, all the jewelries which are seen in the module, they are shining. So this lustrous property of metals is called as metallic luster. What it is called? Metallic luster. Then let's recap what we have discussed in the properties of metals. Metals are malleable as well as ductile. That means metals can be drawn into sheets and it can be drawn into wires. The second property we have discussed is metals, they produce particular sound when struck to a hard surface. Then we have discussed that metals are very good conductors of electricity and also good conductors of heat. As this example you can find in your kitchen itself, so many utensils are used in the kitchen. They are metallic in nature, and when it is kept on the gas stove, definitely that utensil, it becomes hot due to heating. So that shows that yes, the metal is allowing the heat to pass through it. Then we have discussed that metals, they have particular property that is called as luster. Metals are lustrous in nature. They have this shining property. Then the next we have to discuss is the properties of non-metals. The non-metals are non-lustrous, non-ductile, non-malleable, poor conductors of heat and electric current, and non-sonorous. So what does that mean, these properties? Non-lustrous means metals, they don't have shine. Instead, they are dull looking. Then, non-metals are considered to be non-ductile in nature. Now, why they are non-ductile in nature? The non-metals are brittle, very soft. So, if we try to hammer it or we try to draw wires out of it, it is not possible. So, that is why we say that non-metals, they are non-ductile as well as non-malleable also. Because if we will hammer it, if we will take a piece of non-metal and we'll hammer it, like metals were drawn into sheets, as here you can see, it is drawn into sheets. What will happen to non-metals? Non-metals will become powdery. It will be broken down into smaller pieces. That is why we say that they are non-malleable as well as non-ductile. Then the non-metals are poor conductors of heat and electric current. They are not allowing heat and electric current to pass through them, and also they do not produce that particular sound which metals produce when they are struck to hard surface. So we consider that non-metals are dull looking, they are non-ductile and non-malleable, poor conductors of heat and electric current because they do not allow heat and electric current to pass through them. And here we have an exception, and the exception is graphite. Graphite is a good conductor of electric current. It allows electric current to pass through it. Then non-metals are non-sonorous. When struck with hard substance, what will happen to a non-metal? The non-metal, instead of producing that particular sound, it will break into small pieces. So here are few examples of non-metals. Sulfur and carbon, these are the solid forms of the non-metal. Bromine is the only liquid non-metal, and there are many gaseous non-metals. One of the example is oxygen. Now let's see the difference between non-metal and metal. As we have discussed, that metals, they have shiny appearance. But what about non-metals? They are dull looking. Then the metals are solids at room temperature. RTP means room temperature. The only exception in case of metals in the solid form is mercury. Mercury is found in liquid form. And when we talk about non-metals, the non-metals are found in all the three states at room temperature and pressure. The examples you have already seen. The solid form of non-metal was carbon and sulfur. Liquid form was bromine, and gaseous form example we have seen is oxygen. Then the next difference between metal and non-metal is the metals are malleable in nature, ductile in nature, and also sonorous. But when we talk about non-metals, they are brittle if they are in solid form. Brittle means they are soft. Then metals are good conductors of heat, whereas the non-metals are poor conductors of heat. And also the metals are good conductors of electricity, whereas the non-metals are poor conductors of electricity, except carbon and graphite. Then the next topic for the day is the symbols of the elements. Now, John Dalton, as we have discussed in the previous session also about John Dalton, he gave symbols for the elements. Elements, they were represented by certain symbols. The symbol of an element is a single letter or two-letter abbreviation. That is the thought of J.J. Berzelius. But here you can see in the module that John Dalton gave some different signs, symbols, which are entirely different from those which we use nowadays. These symbols were assigned by John Dalton. But later on, J.J. Berzelius, he simplified this system of assigning the symbols and gave different symbols, different pattern for assigning the symbols. Let's see. According to J.J. Berzelius, the symbols assigned to the elements are in three different ways. The first is the symbols of the elements are assigned with the first letter of their English name. As you can see here, so many examples. B for boron, C for carbon, F for fluorine, H for hydrogen, I for iodine, N for nitrogen, O for oxygen, P for phosphorus, K for potassium, S for sulfur, W for tungsten, U for uranium, V for vanadium, and Y for yttrium. So, in these examples of elements, we find that the first letter of their name is taken as symbol, except tungsten. Except tungsten and potassium. In all the other examples, we find that the first letter is taken as the symbol. Potassium and tungsten is exception in this case. It is the third part which we will be discussing after this point. So here we see that there are some symbols assigned to the elements, and these symbols are from their English name itself. That is, the first letter of their name is taken as the symbol. So according to J.J. Berzelius, the symbols were taken from the names of the elements. And here the first criteria that was put by J.J. Berzelius was that the symbols of the elements are written with the first letter of their English name. Now, one point I want you to note down here is that in all the examples, you see that the symbol is written in capital letter. So always remember that whenever you are writing the symbol for any element, that is to be written in capital letter. This is the most important point for writing an element symbol. Now, the second criteria for assigning the symbols was if more than one element has the same first letter, then what should be done? The first two letters, it can be the first two letters or the first letter same with any other letter, can be taken as the symbol. Now here we see all the symbols begin with the same alphabet. Cadmium, calcium, carbon. I'll tell the common examples only now. Cadmium, calcium, carbon, chlorine, chromium, cobalt. All these begin with C, the letter C. So if only C is taken as the symbol, it will create confusion. So in such cases, what was told by J.J. Berzelius, or what symbol was assigned by J.J. Berzelius, was the first letter with any other letter was taken as the symbol. So here in case of cadmium, you can see that it is capital C and small d. Now here also I'll draw your attention. The first letter of the symbol is capital, whereas the second letter of the element name is small letter. So always remember that for any element, if two letters are taken as the symbol, the first letter will always be written in capital letter, whereas the second letter will be written in small letter, as you can see in all these examples. The first letter is capital, except in case of carbon. The first letter is C, capital, and next to it is the second letter in small letter. So this was the second criteria given by J.J. Berzelius, that if more than one element has the same first letter, their symbols consist of two letters. The first letter followed by another letter which is not common. Then comes the third criteria. The third criteria given by J.J. Berzelius was, there are some symbols whose names are derived from their Latin names. As you have seen in the first criteria also, there were two elements, potassium and tungsten. So these elements name is derived from their Latin name, and therefore the symbol assigned to them is also from the first letter of their Latin name is taken as the symbol. In case of potassium, the Latin name is calcium, and in case of tungsten, it's wolfram. That is why W. Now let's come to the third criteria. In the third criteria, you can see here a list of so many elements. Their English name is given with the symbol, and the Latin name is also given from which the symbol is derived. So, antimony is, its symbol is Sb, and the Latin name of the element is stibbium. Copper, the symbol is Cu, the Latin name of it is cuprum. Then gold, the symbol is Au, Latin name is aurum. Then iron, its symbol is Fe, and the Latin name is ferrum. Another element is lead, symbol is Pb, and the Latin name is plumbum. Mercury, its symbol is Hg, and the Latin name is hydrargyrum. Then potassium we have already discussed. It is derived from calcium, so the symbol is K. The symbol for silver is Ag, capital A, small g, and the Latin name is argentum. Then sodium, its symbol is Na, and the Latin name from which this name is derived is natrium. Tin is symbolized as Sn, and the Latin name is stannum. And about tungsten also we have discussed in the first criteria. The symbol is W, and the Latin name from which this name is derived, tungsten is derived, is wolfram. So with this we come to the conclusion that J.J. Berzelius, he gave three criteria for assigning symbols for the elements. The first criteria was that the symbols of the elements are assigned from the English name of the element. The first letter of their English name is taken as the symbol, as in case of boron, carbon, fluorine, etc. Then we have discussed that for some elements, when the element with the same letter are many, if more than one element has the same first letter, then in that case the symbol consists of two letters, that is the first letter with any other letter which is not common, as in case of cadmium, calcium. You can see the first letter is the name is taken from the name of the element, and the second letter is any other letter which is not common. Then the third criteria was that the symbols of some elements are derived from their Latin name, that is in case of potassium and tungsten we find so many are there where the symbols are derived from their Latin name. Now, the next point is the significance of the symbol of an element. What is its significance? Why do we need a symbol for an element? Well, the symbol of an element, it represents the name of the element, and it also tells one atom of that particular element. For example, the element carbon, it is represented by the symbol C. So, if C is written, we can say that it is representing one atom of the element carbon. So, what is the significance of the symbol of an element in chemistry? It represents the name of the element. If we write capital C in chemistry, we will say that we are talking about carbon. So, this capital C is representing the name of the element. And with this letter, we can say that it is showing one atom of the element. Now, let's recap what we have discussed today. We have discussed about substances, that is matter. Matter is classified into elements, compounds and mixtures for systematic study. Then we have discussed that an element is a substance that cannot be split into simpler substances by any means, neither physical mean nor chemical mean. Then we have discussed that element is classified into metals, non-metals, metalloids and noble gases. And the last topic which we have discussed today is that elements are represented by the symbols. Now let me remind you of the home assignment. Whatever home assignment is given is there for you on the school's website, that is www.lfsraptinagar.ac.in. So you can write down the homework that is assigned for you in your fair copies. Your fair copies will be the same type of copy which you were using in class 5. You were using interleaf copy. One side it is blank and the other side it is showing lines. That means one side it is ruled and the other side it is unruled. The ruled side of the paper you need to write your answers, and the unruled side you need to draw the diagrams if it is told. With this we end up today's session. Hope to meet again. Till then, stay safe, stay protected. God bless you.